So our lesson today is about factoring special cases. So this is kind of extending what we've learned already about factoring. And we're basically going to look at three unique situations where you can use a formula to do the factoring for you. So let me give you those three formulas right now, and then we'll look at where they come from. So the first one, I want you guys to memorize this because we're going to use it a lot. These two, I don't care if you memorize them because I don't even have them memorized, but you will need them for your homework. So I'll give you a second to take a picture or write it down. It's also in the first question on your homework. So if you don't get it all the way written down, these formulas are in your first question. Okay, so the purpose of these formulas are to help you with factoring. So remember, the goal of factoring is to take stuff that's added together and convert it into a form where you have things that are multiplied together. So the difference of squares, which is the one we're going to use the most, basically says whenever you have two perfect squares that are subtracted from each other, you can factor them into an expression that looks like this. And A and B can be anything. So you could have, for example, like, I don't know, 16x squared minus 9y squared. If you had a polynomial like that, this fits this form because you have two perfect squares that are subtracted from each other. So what you would do is you would say, okay, well, what are the things that are squared? Well, 16 is 4 squared. X squared is obviously x squared. And so in this case, the A would be 4x because 4x squared gives you this. And then on this one, what would B be? Yep, 3 would be in it, and also y, because you'd have 3y, and if you do 3 squared, you get 9, y squared gives you that. And so the factored version of this would be 4x plus 3y times 4x minus 3y. Is everybody good with that? That's pretty much the main idea of this lesson. But I want to show you guys where these formulas come from because it's actually kind of, well, I think it's interesting. I totally don't, I'm not offended if you guys don't think it's interesting, but I'm going to show you guys where it comes from. So if we look at this, remember factoring is basically undoing multiplication of polynomials. So if we multiply these together, we should get the a squared minus b squared in the formula. And if we multiply that out, a times a gives us a squared. A times negative b is negative ab. B times a is positive ab. And b times negative b is negative b squared. That's just from FOILing that out. And the thing that makes this unique is that you have a negative ab plus ab. And those end up adding together to 0. And that's why it equals a squared minus b squared. And so essentially this is a special form because the middle terms end up canceling each other out. And something similar happens when you do I think that's a difference of cubes, but we'll find out. So if I do a times a squared, that equals a cubed. A times ab gives me a squared b because I have two a's and a b. A times b squared gives me ab squared. And then if I do negative b times a squared, I get negative a squared b. Negative b times ab is negative with 1a and 2 b's. And negative b times positive b squared gives me negative b cubed. And if you look at this one, we have a similar thing happening where you have a positive a squared b and a negative a squared b. So those cancel each other out. And we have an ab squared and a negative ab squared, and those cancel each other out, which is the reason why this ends up equaling a cubed minus b cubed. And we won't go through this one because it basically looks the same. You just have some different positives and negatives. But essentially, the special cases come from very specific situations where all the middle terms end up canceling each other out. And you only end up with like the cubes or the squares or something like that. And so that's where these formulas come from. And they're useful because they allow us to factor things that maybe we typically would have no idea how to factor. And so we're going to be using these three formulas. And there's also two other formulas that are classified as special cases. I personally don't find them very useful though, because the way that they work is if you have a polynomial that fits this form, you can factor it to be a plus b squared. But I don't really find that very helpful because it's like, this is a rather complicated form, like, what's the word? Polynomial. And it's kind of hard to tell whether or not the polynomial fits that form or if it's just a regular trinomial like we were factoring last time. And so I wouldn't necessarily recommend even writing these down because in my opinion, they're not very helpful. So let me actually show you one of the problems from the homework that does involve these, just so you can see where, because they will come up a couple times on your homework, but I don't want to go into too much detail on it. This one. Okay, so on this one, you're asked to factor what they call a perfect square trinomial. And when we factor this, you could, in this case, like this does fit the form of one of those two special cases, but I think it's easier to just do what we did yesterday. So you'd say like x squared times 4 is 4x squared. And what are two things that multiply to 4x squared and add to, in this case, 4x? Yep, 2x and 2x. And so I could split this up and I get x squared plus 2x plus 2x plus 4. Split those into two groups. The first group has an x in common. The second group has a 2 in common. And you end up with x plus 2 times x plus 2. And this is why it's called a perfect square trinomial, because you have two things that are the exact same multiplied together, and that gives you x plus 2 squared. So you could use those other formulas I showed you if you wanted to, but I don't think it's worth the trouble of trying to figure out whether or not the trinomial fits that form. And so that's, I would just do it this way. Now there is one question on your homework. It is question 14, where they ask you to factor a perfect square trinomial that involves a fraction. So the main thing to know with this is that perfect square trinomials will have the same numbers when you split it up here. Like that's kind of like one thing that's consistent with all perfect square trinomials. So the fact that on question 14, they tell you this is a perfect square trinomial, it will help you a lot with the fractions, because when you say, I'm gonna write this out so you can see it because it's a little small. So we have a squared minus 3a plus 9/4. So if we were to solve it the way we did it yesterday, we would take 9/4 times a squared, and that would give me 9/4 a squared. And I need to find two things that multiply to that and add to -3. And because they told me it's a perfect square trinomial, I know that those two things are going to be the same thing. And like, if I think about, well, what two things that are the same multiply to this? Well, I could just take the square root of that, because the square root like tells you what two things would multiply together to equal that if they're like the same. And so in this case, it would be 3/2 a and 3/2 a. Well, actually, I think it'd have to be negative because we want it to add to a -3. So they'd both be negative, actually. And if you test that out, -3/2 plus -3/2 is -6/2, which is -3. And so that's kind of how you would deal. Like, I guess it is kind of useful to know it's a perfect square trinomial when you have fractions, because if you had no idea like what types of fractions to start guessing, that might be really difficult. But that's how you would do one like that. So in general, I wouldn't recommend using these two formulas for perfect square trinomials, just because the formulas are really complex and you can just do it the other way instead. So these are the three formulas I would recommend using. And this one is the one you need to memorize. You don't have to memorize these two. They won't be on the test, but we'll be using this one a lot. So this is one that you'll want to memorize. Okay, so let's apply it. So in this case, do we have a difference of squares, difference of cubes, or sum of cubes? So, sorry, let me go back because I didn't talk about the names. So difference of squares. Yep, you got it. So difference of squares is where you have two things that are squared. Difference of cubes is where you have two cubed things, and sum of cubes is where you have two cubed things. And we don't have a sum of squares because the only way that you can factor a sum of squares is if you use imaginary numbers, and we haven't learned imaginary numbers yet. So if you ever have something squared plus something squared, it's impossible to factor it further unless you use imaginary numbers. So coming back to this one, this is a difference of squares. And what is the first thing that's squared? X. So in my formula where I have a squared minus b squared equals a minus b times a plus b, the a in this case is going to equal x. And what would be the b? Yep, it's going to be 7 because 7 squared equals 49. So to figure out what a and b are, you basically take the square roots of the two things that are added and subtracted together. So to factor this out, I just use my formula and say that this factors out to, x minus 7 times x plus 7. And this is the factored version of x squared minus 49. And if you were to FOIL this out, you would get something very similar to what we got when we FOILed out a minus b times a plus b, because your negative 7x would cancel out the 7x. So that's how you do that one. What about on this one? How would we factor this one? Okay, I heard someone say 6x. So we'd have 6x, then what? Yep, 4y. And when I factor this, I'm going to have one that's subtracted and one that is 6x plus 4y. Now, this is not fully factored because these factors can be factored even further. What does this factor have in common? A 2. So I could write this as 2 times 3x minus 2y. What does the second one have in common? Yep, also a 2. So I could write that as 2 times 3x plus 2y. And we could simplify that because 2 times 2 is 4. So we would write this as 4 times 3x minus 2y. And 3x plus 2y, like that. So this would be fully factored. And you always want to check whenever you do factoring to see if you can factor it further. Because if your factors can be factored further, then you need to do that, especially if the instructions say to factor completely. Now, this one you could have actually done a different way if you had started with greatest common factor factoring, because both of these have a 4 in common. So you could have started off the problem by saying, well, if I factor out a 4, I would get 9x squared minus 4y squared when I factor out a 4 out of both of those terms. And this can be factored further because it's a difference of squares. And you would get 4 times, if I take the square root of 9x squared, I get 3x. And then this one is 2y squared. So I get 3x plus 2y and 3x minus 2y when I do the difference of squares. And you can see you get the same answer either way. But I would usually recommend doing it this way and factoring out the greatest common factor, especially if you have huge numbers. Like if this was like 3,600 minus 1,600, you would definitely want to factor out the hundreds before you start doing the difference of squares thing. And sometimes you don't have an option except for to factor it out first. Because in this case, it looks like it's almost a difference of squares, but 90, you can't do the square root of it and get a whole number. And so in this case, you'd want to factor out the 10 first, and then you would have 9 minus x squared, which is a difference of squares, and you could write it as 10 times 3 minus x, 3 plus x. And that would be how you'd factor that. So in general, just factor out the largest or the greatest common factor first, because that's the easiest kind of factoring, and then look at the stuff that's left and see if you can factor it further. But in some cases, you can still solve the problem. It will just take you longer, but it's always easier if you factor out the greatest common factor first. Yeah. Any questions on this so far? Okay. Can you guys let me know on a scale of 1 to 5? How are you guys feeling about difference of squares? Okay. Do you guys have any questions on it or how it works? Okay. So again, basically the strategy is if you have two things that you could take the square root of and you subtract them, then you can factor it out into these types of factors. So like the square root of 9 is 3 and the square root of x is x. So you factor it into 3 minus x and 3 plus x. And that's the difference of squares. You will also have, oh, this one's kind of an interesting one. So this one, we have x to the 4th minus 81. So you can take the square root of x to the 4th because what times itself equals x to the 4th? X squared. So we could factor this to be x squared minus what's the square root of 89? Or 81, I mean. 9. So I'd get x squared minus 9 and x squared plus 9 when I use the difference of squares. And on this one, you would actually have to use the difference of squares again because you have an x squared minus 9, which is also a difference of squares. So you would factor that into x minus 3, x plus 3, and then you would have the x squared plus 9. And you can't factor this because you can only factor sums of squares if you have imaginary numbers. So on this one, we kind of used the difference of squares twice. So we went and we said, okay, well, x squared minus 9 squared, you can factor it into these two parts. But then this can be factored even further because x squared minus 3 squared could be factored into these two parts. Does that make sense? Okay, so that turned into that. So you have some problems like that. And then you also have some problems like this. So what is this problem? Like out of all of our special cases? Yeah. So I don't have this memorized. So let me go back to this and write it down. Maybe. There's no markers. And I didn't bring my bag today. Do you guys have that written down? Can you tell it to me? Okay. So I know that the difference of cubes says that a cubed minus b cubed equals, I think it starts out with a minus b, is that right? And then it's like a squared, is it plus? Okay. So I can never, like, I know the general structure, but I can never remember which ones are plus and which ones are minus because the sum of cubes is the opposite. So once you have that formula, the main thing is to figure out what a and b are. So if we look at our first term, this is the term that's in the spot of a. So what cubed equals 64x cubed? Yep, so a is going to equal 4x because if you do 4 times 4, that's 16. And if you multiply by another 4, that's 64. And obviously x cubed equals x cubed. So a is going to be 4x. And then the y cubed is in the spot of b cubed. So that means that b equals y. And so to factor this, I'm basically going to go through and plug in a 4x everywhere I see an a, plug in a y everywhere I see a b. So I'd say, okay, I have 4x minus y times 4x cubed, or sorry, 4x squared is going to be 4 squared, which is 16 times x squared. And then a times b is going to be 4xy. And then b squared is just going to be y squared. And so this would be my factored form. And no matter what these numbers are, it's actually impossible to factor this any further without using imaginary numbers. So there are some trinomials that cannot be factored, and we'll talk about them. Well, I think we'll talk about them a little bit when we get to quadratic equations. But for the most part, your homework doesn't have trinomials unless you can factor them. The exception to that, though, is when we do difference of cubes or sum of cubes, because the format that this ends up turning into makes it impossible to factor without using imaginary numbers. So you don't have to factor this any further. But typically, unless it's like a sum of cubes or difference of cubes, if there is a trinomial, it will most likely be factorable. So you'll want to check and see if it is. So that's how you would do a difference of cubes. Any questions on that? Okay, and sums of cubes are basically the same thing. You just have plus and minus. Some of the signs are switched. All right, so those are all of the examples I wanted to go over to start class. I'm also going to go over question 7, question 8, and question 10. So if you guys want to open up your homework, I'll probably start on question 7. All right, so on question 7, when I look at this, I basically have 2 terms that are being subtracted. And it looks rather complicated. However, if I notice that this is a perfect square, because I have a minus 5 squared, and then this is a perfect square, then that means I can just use my difference of squares formula. And so what that would look like is I would say, okay, well, the first part is a minus 5. And when I factor that, I'm going to have a minus 1, and then I'll have an a minus 5 plus 1. Is everybody good with how I got that? So essentially, like I said, I have this thing squared minus 1 squared. So if I take the square root of that, that gives me a minus 5. If I take the square root of 1, that gives me 1. So I have a minus 5 minus 1 and a minus 5 plus 1 based on difference of squares. Yeah.
What if we have a plus?
A plus in here? Yeah. That's fine because it's still like this stuff is squared. If you had a plus here, it wouldn't be factorable, at least with this method. Yeah.
So it looks the same, but it'd be.
But these two would be pluses. Yeah, because it's kind of like, it's essentially like we're factoring x squared minus 1, which would be x plus 1, oops, x minus 1, x plus 1. But instead of having an x, you have whatever this stuff is. So in my case, it was a minus 5. In your case, it'd be whatever your plus is. And you can simplify this further because negative 5 minus 1 is negative 6. So you'd get a minus 6, and negative 5 plus 1 is a minus 4. So you can simplify that further, and this would be the fully factored version of that. There is another way you could also solve this problem. This one's definitely the easier way, but another way you could solve this problem is you could FOIL this out, and you could figure out what polynomial this is and combine that polynomial with negative 1. And you'd have like a squared plus something a plus some number. And you could factor it using the method we did yesterday, and you would still end up with this answer. But it's not the easiest way, so I wouldn't recommend it. The what?
When I did it.
What was yours?
It was parentheses x plus 4 squared minus 4.
Okay, and how did you write it out?
So I just did x plus 4 plus 4.
So 4 squared doesn't equal 4. Because these are perfect squares subtracted. And you need to take the square root of them to use the perfect or the difference of squares formula. Because the difference of squares says if you have 2 perfect squares subtracted, that equals this.
Okay, I just put it because I saw -1 and you put -1 and +1.
Oh, gotcha. Yeah, that's because the square root of 1 is 1.
Okay.
But in your case, because it's a 4, the square root of 4 would be 2. Yeah, so if you switch it to a 2, then that should fix it. Sorry, that I guess that was a bad example because, yeah, this one is not because like this one is the square root of this one. So if you had something like this, you would do minus 2 and x plus 4 plus 2. Because you do the square root of 4 to get this number. Does that make sense? It's kind of like in this, like you'd say A equals x plus 4 and B equals 2. Because you have this squared and this is 2 squared. Does anybody have any questions on that? Okay.
And then x minus 2.
Should be-
That's a negative 1, sorry.
It should be, yeah, it should be, yeah. I think yours would be x plus 6 and x plus 2. Okay. The next one I want to go over is question 8. So this one I would say is probably the hardest one on the homework. And the reason for that is because of the way that they set it up. So if we have this polynomial, when we first look at it, we might be inclined to say, oh, let's do factoring by grouping because there's 4 terms, so we could split it up into 2 groups. However, if you split it up into 2 groups, this one would have a c in common and you'd get c minus 2z. But this one doesn't have anything in common, so you'd get plus 1 times z squared minus x squared. But this parentheses stuff doesn't match each other, so you couldn't do factoring by grouping. So kind of cut that out. Even though there's 4 terms, factoring by grouping doesn't end up working because of what the terms are. And so when we look at it, we're like, okay, well, there's a lot of stuff squared, and like we have some subtraction, but we also have this thing which isn't squared. So the fact that we have so many squareds means that I will probably end up with something squared minus something squared, and I'll use the difference of squares, especially given the fact that this question is in the lesson that's all about difference of squares. So I need to figure out some way of making this stuff look like something squared minus something else squared. And truthfully, this actually took me a little while to figure out, so I'm just going to tell you guys the trick for it. You want to factor this, and you factor just that, and then that stuff will be a perfect square. So like you'll get 2 things multiplied together, but they'll be exactly the same. And then you'll use the difference of squares from there. So if I focus on just factoring that, that's a trinomial. So I can use what we learned yesterday, multiply my first and last together, and I get c squared, z squared. And what are 2 things that multiply to cz squared but add to negative 2cz? Perfect. Yep. 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 Because if I do negative cz times negative cz, that will give me positive c squared z squared. If I add those together, that will give me negative 2cz. So many c's and z's. So I'm going to rewrite that as c squared minus cz plus z squared. And I still have this minus x squared out here, but I'm just going to ignore that for right now and focus on factoring just this. So I look at this and I say, okay, well, if I split that into 2 groups, I get c times c minus z. On the second one, I get a negative z in common, which leaves c minus z. And I still have my minus x squared out here. And then these 2 terms have a c minus z in common. So I can factor those out and I get, whoops, c minus z times c minus z. I still have my minus x squared, but all of this stuff ended up factoring into 2 things that are exactly the same. And so that means I can rewrite this as c minus z squared minus x squared. Now, this is a difference of squares because I have something squared minus something else squared. So I can use my difference of squares formula, which says a squared minus b squared equals a minus b times a plus b. So this is the formula that we learned in class. And that I would recommend you memorize. So in this case, this stuff is A, this stuff is B. Because I have something squared minus x squared. And so the way that I would factor this is I would write it as, well, I have A minus B, so minus x, and then I have A plus B, which is x. And so this would be the factored version of that. And that's how you would do that one. So this one is definitely the hardest one on your homework. So the main trick is take the first, like the trinomial that looks like it could be factored, factor it out. And if you do it correctly, you should end up with two factors that are exactly the same. That's going to be your first thing that's squared, and you're subtracting the last term that you just kind of brought along with it for the entire time. And I guess this might be one situation where the two formulas where I told you guys I wouldn't worry about memorizing them. If you did have them, you might recognize that that's in that form of those two formulas. And so that might be one place where it would be useful. But there will definitely not be anything like that on the test. So there's that one. And then the last one I just wanted to mention, I'm not going to go through the whole thing, but this one's very similar. This is question 10. And it's very similar to what we did in class yesterday, where you have three terms that are being added and subtracted, and all of those terms have an x minus 4 in common. So you would pull the x minus 4 out, and then you'd be left with x squared minus 2x plus 1 in this case, because this term divided by x minus 4 is x squared. This term divided by x minus 4 is negative 2x, and this term divided by x minus 4 is plus 1. And so then you would take this and you would factor that further. And given the fact that it's in this lesson, this is probably going to end up being a perfect square trinomial. And so you'll end up with two factors that look the same. And that's how you do that. So if this one isn't fully finished, you need to still factor this trinomial out. But the hardest part is just recognizing that you can pull the x minus 4 out. All right, so those are all the examples I thought would be helpful to go over. But if you guys have any questions, let me know and I'm happy to help.